Okay, so in today's session, I wanted to discuss the inverse of exponential functions. Okay, so let's say we have the exponential function of this form, okay, where b is greater than 1 and where b is not equal to 1. Okay, so these are the restrictions that we are we are setting for the variable b. Okay, so to obtain an inverse function, okay, so to get an inverse function for any function, we have to follow these basic steps. Okay, so to get an inverse, we need to follow these steps. Step number one, we need to swap the variables x and y. Okay, and then step number two, we need to make y the subject of the formula. Make y the subject of the formula. Make y the subject of our formula. Okay, so let's determine the inverse of y is equal to b to the power of x. Okay, so we have f of x, which is equal to y, which is equal to b to the power of x. Okay, now if we are looking to obtain the inverse, um, f to the negative 1 of x. Okay, so this is how we denote the inverse function in functional notation. Okay, so step number one, we said that we have to interchange, or we have to swap x and y. Okay, so if we do that, we obtain x is equal to b to the power of y. Okay, and then step number two is that we have to make y the subject of the formula. Okay, now to make an exponent, okay, to make an exponent the subject of the formula, to make this guy the index or the power or the exponent the subject of the formula, we have to make use of logs, okay, or logarithmic functions. So what will happen is that the value of y is given by log of base b of x. Okay, so this is how we isolate the value of y, okay, using logs. Now we have to understand that this is the exponential form, exponential form, and then this is the logarithmic form. Okay, so these two equations, they say, or they mean the very same thing. They just say the very same thing in different ways. Okay, so these two equations are equivalent to each other. Okay, so the most important step is step number one, the swapping of the x and y. So to obtain the inverse, number one, we swap x and y, and then we make y the subject of our formula. Okay, so let's do a, a real example now. Let's say we have an exponential function given by this form, y is equal to 2 to the power of x. Okay, now to obtain the inverse, we have to, number one, swap x and y, meaning that we will have a situation like this. Okay, and then number two, we need to make y the subject, meaning that we have to use logs. So we will have y is equal to log of base 2 of x, like that. Okay, and then we can do another one. Let's say we have y is equal to a half raised to the power of x. Now, if this is the case, then we we follow the same rules that we were following previously. Number one, we swap x and y, and then we end up with x is equal to 1 over 2 raised to the power of y. And then we make y the subject. So we will have a situation like this. Y is equal to log of base a half of x, like that. Okay, so these are the simple steps that we follow when we are trying to obtain the the equation of the inverse function. Okay, so this is the equation of the inverse. Okay, now before I continue talking about the inverse, let me just digress a little bit. So there is this, which is the inverse. Okay, so this is the inverse of f of x. Okay, and then there is this. This is the reciprocal of f of x. Okay, so these are very important notations that we have to be able to distinguish, because I've seen a lot of students confuse these two notations. I know they they might be similar, but then they are not the same at all. They mean two different things. Because for for the first one is the inverse, but then for the second one, we are basically saying 1 over f of x. Okay, so for the first one, we have to interchange x and y, but then in this situation, we just need to take the reciprocal, which is 1 over the function f of x. Okay, so that is a very important side note. Okay, now let's continue our discussion on inverse functions. Okay, so what is an inverse function graphically? Okay, so let's say the function that we are dealing with is y is equal to 2 to the power of x. Okay, y is equal to 2 to the power of x. Now, if I sketch this graph, it will look something like this. So I will have my y-intercept at x is equal to 0, y is equal to 1. So let me put the point there. And then my graph will be an increasing function. Okay, it will be an increasing function like that. Okay, and then this point has the coordinate of x is 0 and y is 1. Now, if you are not particularly sure how I got the shape of this graph and how I managed to sketch this graph, you can check our videos on sketching basic exponential functions. There we explained in detail how to sketch exponential functions of this sort. Okay, so you can check that out. Okay, so this is the f of x. Okay, so f of x is equal to y, which is equal to 2 to the power of x. Now, so this is the graph of f of x. Now, we must note that graphically, the the inverse function, the inverse function is the graph that is the reflection of f of x over this line that I'm drawing. Okay, so this line has the equation y is equal to x. Okay, so if I take this white graph and I flip it over this line of y is equal to x, whatever graph that I will get is the inverse of f of x. Okay, so in other words, the graph of f of x will look something like this. Okay, so we can write the point. So the point will be x is equal to 1, y is equal to 0. Because remember, we swap all the x's and all the y's. So our point will be somewhere over here. Okay, and then our graph will look something like that. No, something more or less like that. And then, okay, so that's much better. So this is the inverse function. So this is f inverse of x. Okay, so the point is that the inverse function is basically the reflection of the function over this line, which is the line y is equal to x. Okay, let's do another example. So let's say f of x is equal to y, which is equal to a half raised to the power of x. Okay, now let's sketch this graph first. Mm, nope, this is not a straight line. Okay, so the y intercept of this graph will be at x is equal to 0 and y is equal to 1. So let's place this over there. And then based on the properties of exponentials that we established in our previous sessions, we know that this graph will be a decreasing function. So it will be something like that. Okay, so it's just a decreasing exponential like that. Okay, and then this point has the coordinates of 0 and 1. Okay, so to get the inverse, we know that the inverse graph is the reflection of the white graph over this line. The inverse is the reflection of the white graph over this pink line. So our F inverse would look something of this sort. So we can go like that, and then we can go like that. Nope, it looks something like that. Okay, so mm, graph is not doing what I want it to do. Let's try again. Okay, so it will look something of that sort. Okay, so this is the inverse function, and then this point is given by x is equal to 1, y is equal to 0, and then this is the point of intersection of the two graphs. Now, it is very important to note that the the properties of an exponential function. So we know that for the exponential function, the we have the asymptote, that is the asymptote, which is given by y is equal to 0 in this case, or the x-axis. Okay, and then we take note of the fact that the intercept, the y-intercept, is given by this point, and then we take note of the fact that the domain, okay, so the domain of the graph is given by x is the element of all real numbers, okay, and then the range of the graph is given by y is greater than 0. Okay, so this is the range. Now we have to take note of what is happening. So these features are the features of the white graph. Okay, now for the yellow graph, the asymptote, the asymptote changes. Instead of it to be y is equal to 0, it is x is equal to 0. Why? Because for us to obtain the inverse, remember, we had to interchange or to swap x and y. Okay, so this is the new asymptote. X is equal to 0, and the line x is equal to 0. We know that this is the y-axis. Okay, and then the the intercept that we now have is the x-intercept, not the y-intercept. And then the coordinates of the x-intercept, we will obtain this by swapping this point around. So we have 1 and 0 like that. Okay, and then the domain of the function becomes the range of the inverse. Okay, so the the range of the inverse will be given by y is the element of all real numbers, and then the range of the function is the domain of the inverse. Okay, the domain of the inverse. So now the domain of this inverse function is x is greater than 0. Okay, and we can see these restrictions on our graph, that there is, if we look at the yellow graph, there is no restriction on the y. Okay, so this graph can go up until positive infinity, it can go down until negative infinity as far as the y values are concerned. But then if we look at the x values, we can see that there's no graph around this point. Okay, the yellow graph does not exist. So it means that the graph is limited for values that are greater than 0, okay, or between 0 and positive infinity. So that is the domain of the inverse function. Okay, so it is very important to note that the swapping or the interchanging of the x and the y, it doesn't just apply to the points, but then it applies to everything. It applies to the asymptote, it